let's do a little review of the things we've learned about complex numbers and number systems so far. This chart should look familiar. We've been working with it to classify numbers. I want to give you some examples of numbers and then we're going to place them in the chart. So let's start with the square root of -75. Now when you see a radical, what you want to do is simplify it as much as possible before you start to classify it. And so to simplify this number, we see that negative under the radical, which we know always comes out and turns into an I. And then we see that square root of 75, which we want to break down into 3 times 25. And we can either notice that 25 is a perfect square, or we can keep breaking down into 3 times 5 times 5. And that won't break down any further. Since it's a square root, this twin pair of numbers gets to come out and it turns into a 5. But then this number 3 that's by itself has to stay inside the radical. So this will actually simplify to the 5i that's on the outside times the square root of 3. Since that has an I in it, it belongs in the complex numbers. So the square root of -75 will go in complex numbers right here. The next number we're going to look at is the square root of 75 minus 5 square roots of 3. And we just simplified the square root of 75, although it was negative. So if we look at the square root of -75 compared to the square root of 75, the only difference is this is positive, so it's not going to have an I. So the square root of 75 will simplify to 5 square roots of 3. And then we have minus 5 square roots of 3, which actually is going to add to 0. So the value of square root of 75 minus 5 square roots of 3 is equal to 0. And that actually is going to belong in the whole numbers because it's not a counting number or a natural number, but it does go in whole numbers. So the square root of 75 minus 5 square roots of 3 goes right in there. The next number is the square root of 35. It's a radical, so we want to start trying to break it down. 35 would be the same as 5 times 7. 5 and 7, neither one will break down, and neither one has a partner, so both of those values are stuck inside the radical, so that actually is going to remain square root of 35, which is going to be irrational. Next up is 6i squared minus 5i. 6i squared minus 5i. Oh, remember that I squared is always -1, so it is going to change into a -6. So that's going to be -6 minus 5i, which has an I in it and can't be simplified any further, so that's going to need to be complex. So we'll put 6i squared minus 5i in complex numbers. The next one is going to be 7.62 with a bar over the 62. That symbol with a bar means that it's a repeating decimal. The definition of irrational numbers is it is a decimal that does not repeat and never ends. And a rational number is a number that can be written as a fraction, and it includes all decimals that either end or repeat. Since we've got a repeating decimal, it's going to go into the rational numbers category, which will be 7.62 repeating, goes right in there. And our last value is going to be the square root of 121. 121 breaks into 11 times 11. That is a partnership. So the 11 times 11 comes out, turns into a single 11. And there's nothing left inside the radical, so that actually just simplifies to a regular 11, which is one of our natural numbers. So 11 is going to go in the natural number category, so I'm going to write square root of 121 right in there. Let's practice some of our other concepts that we've learned this unit. Let's simplify the square root of negative 108. When we have a radical with a negative underneath, that negative, if it's a square root, is going to come out and turn into an I. Then the 108 we want to try and break down. Let's see, 108 could be 2 times 54. I don't have any pairs yet, so I'm going to keep going. Bring the 2 down. 54 could be 9 times 6. Still don't have any pairs, so I'll keep going. 2 times 9 is 3 times 3, and then 6 is 2 times 3. I do have some pairs at this point. I have a pair of 2's that will come out and turn into a 2, and then a pair of 3's that come out and turn into a 3. Then I have this 3 right here that is going to be stuck inside the radical. So outside the radical I have a 3 and a 2 and an I. And it's important to remember that those are multiplied by each other and then multiplied by the radical and whatever's left inside, which is in this case a 3. I'm going to go ahead and multiply these values out here. 3 times 2 times I is 6I, and then times the square root of 3. And that is as simple as that one gets. Okay, how about adding and subtracting complex numbers? Let's add negative 5i plus 2 plus 7i minus 3. Right away we should notice that those are not in standard form. We can still add them by combining like terms. I have negative 5i plus 7i, and I have positive 2 minus 3. So that would give me negative 5i plus 7i is 2i, and 2 plus negative 3 is minus 1. Remember that we want to write that in standard form, which is the real part first. So keep that negative with the 1. Negative 1 plus 2i. Another problem. Negative 5i plus 2 minus 7i minus 3. Notice this is a subtraction problem. So you want to remember that this negative or subtraction symbol goes to both of the terms in the parenthesis that follows it. So when I combine my like terms, I have negative 5i and negative 7i, which is negative 12i. And I have positive 2 in the first parenthesis, and then minus negative 3 makes plus 3. So positive 2 plus 3 is plus 5. And again, we want to put our answer in standard form. So the real part first, which is positive 5, the imaginary part second, which is minus 12i. Let's move on to some multiplication. Let's start off by multiplying two complex numbers. So when you see two parentheses that are next to each other like this, negative 5i plus 2 and then 7i minus 3, that means multiply even if the directions don't say multiply. It's assumed that two parentheses next to each other mean to multiply. So we are actually going to FOIL in this problem. So we'll take first times first. Negative 5i times 7i is negative 35i squared. Outside times outside, negative 5i times negative 3 is positive 15i. Inside times inside, positive 2 times 7i plus 14i. And last times last, positive 2 times negative 3 is negative 6. Remember that we're going to change that I squared to negative 1, which makes this term positive 35 with no I. And we'll combine the positive 35 with a negative 6 because they're both real numbers. to get 29, and then 15i plus 14i plus 29i. And that is in standard form, so we're finished with that problem. Let's look at a little bit more complicated example, like 4i minus 2 plus 3i times 7 minus 5i plus 8i. Although this problem looks a little bit overwhelming at first, it's really just kind of the same problem as like 10 minus 2 times 3 plus 6. So what we'll want to do first is this multiplication, and then we will be adding and subtracting left to right. So in this problem, the first step is going to be foiling. So we'll want to keep the 4i minus. Keep your product in a parenthesis so we don't forget to distribute that negative across. And then we'll FOIL 2 times 7, 14. 2 times negative 5i minus 10i. 3i times 7 plus 21i. And 3i times negative 5i minus 15i squared. End your parenthesis, and don't forget your plus 8i at the end. Then we'll simplify inside those parentheses, remembering that this I squared causes this term to change to positive 15 with no I. So we'll have 4i minus, parenthesis, 14 plus 15, 29. Negative 10i plus 21i is plus 11i. And then close your parenthesis and don't forget your plus 8i at the end. And now we're ready to combine like terms. Remember, this negative distributes into both of those terms. So I start out with my real numbers, imaginary, and then I got negative 29 is real. That's imaginary, that's imaginary. So the only real number is negative 29. And then I'm going to combine my imaginary numbers. 4i and then minus 11i would be negative 7i, plus 8i would be positive 1i. We usually don't write that 1, so we end up with negative 29 plus I. How about those raising I to a power problems? How about I to the 230th power? Remember that when you raise I to a power, there's a pattern of 4 repeating values that we need to remember. If it's I to the first power, it's just I. If it's I squared, it's negative 1. I to the third power is negative I. And I to the fourth power is 1. So our strategy for figuring out what I to the 230th power is to take that 230 in the exponent and divide it by the 4 in our repeating pattern. So 4 goes into 23 5 times. Minus 20 is 3. Bring down the 0. 4 goes into 30 7 times. Minus 28 is 2. We're going to use that remainder to rewrite our exponent. Instead of I to the 230th, that is going to be equal to I to the second power. And then we just remember our pattern of 4 repeating. And since I squared is negative 1, I to the 230 is equal to negative 1. How about rationalizing denominators? Let's see. How about 12 over 5i? This is a denominator with a complex number. So what we want to remember to do is multiply by the complex conjugate over the complex conjugate. Since the denominator is 5i, its conjugate is negative 5i. So we want to multiply by negative 5i over negative 5i. 12 times negative 5i would be negative 60i over 5i times negative 5i is negative 25i squared. Remember that I squared gets replaced with a negative 1. So our denominator is actually going to change to a positive 25 with no i's. So we really have negative 60i over 25. And that can be simplified by dividing out a 5 in each. Negative 60 divided by 5 is negative 12. And 25 divided by 5 is 5. So we have negative 12/5, and you want to remember to put the I big and down to the right of that fraction. So negative 12/5 I. Another type of problem for rationalizing the denominator is one with a radical. Let's look at 6 over 11 square roots of 5. This is one that does not have a sum or difference, so it's an easier type of problem. In these kinds of problems, you just have to multiply by the radical over the radical. So I don't need the 11, it's just the square root of 5 over the square root of 5. And we multiply that. 6 times the square root of 5 is 6 square roots of 5. And then 11 square roots of 5 times the square root of 5. We have 11 times 1 is 11. And square root of 5 times square root of 5 is 5. So we end up with 6 square roots of 5 over 55. And we want to check to see if we can simplify, but remember you cannot simplify this 5 inside the radical with anything outside the radical. So this problem will not simplify any further. The last types of problems we have are still rationalizing the denominator, but they are going to be problems that are more complex than what we've done so far. So let's look at these two problems. One with a complex denominator, 5 minus 8i over 3 plus 2i, and the other with a radical that has a difference in the denominator, a subtraction problem. Now the way that these two problems are similar is that the strategy is going to be to multiply by the conjugate of the denominator over the conjugate of the denominator in both of them. So in my complex one, 3 plus 2i, the complex conjugate of that is going to be 3 minus 2i. So I need times 3 minus 2i over 3 minus 2i. Don't forget to put your parentheses around so that you will remember to FOIL in the numerator and denominator. Let's go ahead and do that. We get 5 times 3, which is 15. 5 times negative 2i, negative 10i, negative 8i times 3, negative 24i, and negative 8i times negative 2i, plus 16i squared. In the denominator, we have 9 minus 6i plus 6i, and then minus 4i squared. Remember to use your I squareds to change the signs of those terms before you combine like terms. So now I've got 15 minus 16 is negative 1, and then minus 34i over, these two drop out, so I just have 9 plus 4 is 13. Okay, this is one of those weird looking problems where we have to remember to split it. So we're going to write negative 1 over 13. And then since we have a subtraction problem, it will be minus 34 over 13 with the I tacked onto the end. In our radical problem, we're going to start by multiplying by the conjugate of the denominator over the conjugate of the denominator. Since it's 3 minus the square root of 5, we're going to multiply by 3 plus the square root of 5 over 3 plus the square root of 5. Again, I want to remember those parentheses because that gives me a visual reminder that I'm going to be foiling and foiling. So we'll take first times first, 15, outsides plus 5 square roots of 5, insides minus 7 square root, that will be 21 square roots of 2. Then last times last minus 7 square roots of 10 over first times first, 9 outsides plus 3 square roots of 5 insides minus 3 square roots of 5, and last times last is negative 5. Combining like terms in the numerator, it doesn't look like there's anything that's going to combine, because none of these radicals can simplify, and they're not like terms if they don't have the same radicand. So I'm just going to rewrite my numerator. In the denominator, these two terms with the radicals add to 0, so they're gone, and I just have 9 plus negative 5, which is 4. I want to check to see if I can simplify, but in order to simplify, this 4 would have to have a common number that can be divided out with all 4 terms. So the 15, the 5 coefficient, the 21 coefficient, and the 7 coefficient. Since nothing can divide out of all 4 of those terms, this is as simple as we can make this problem. Good luck on your quiz. Remember to study.